So if you remember what we discussed yesterday. Okay, so can you see the screen?
Yes, sir.
Yes, sir.
Okay, so what we were discussing yesterday. Okay, do you remember that if xn is a sequence of non-negative numbers, then limit is also non-negative, right? This we discussed yesterday. Yes.
Yes.
So if xn and yn are sequences such that xn is less equal yn, then xn, limit of xn is less equal limit of yn, right? Have you proved it? Okay, just a minute. I will start lecture within 5 minutes. So there is some uh, connection problem. So just wait for 5 minutes. I will start in 5 minutes. Okay. Okay, can you hear me?
Yes, sir.
Okay, so today last time we discussed about if xn is a sequence of non-negative numbers, then we saw that limit is greater or equal 0. So if xn and yn are sequences such that xn is less equal yn for all n, then limit of xn is less equal limit of yn. Right, and I think proof is trivial. In this case, proof is not difficult at all, right? So we understand proof is easy. I just gave hint yesterday. You just use
Yes,
the
sir.
Yes, sir.
right. So now we want to extend. We want to make this idea more general. Of this right. So how to make this idea more general? So yeah, just a minute. Okay. Can you see the screen?
No, sir.
Just a minute.
No, sir.
Okay. Okay. Can you see the screen now? Is my screen visible?
Yes, sir.
Okay.
Yes, sir.
Okay, so we want to generalize this idea, and how to generalize. So this theorem, squeeze theorem, or sandwich principle. So what sandwich principle says? So it says that suppose there are three sequences xn, yn, and zn are sequences of real numbers such that, so we have three sequences xn, yn, zn such that xn less equal yn less equal zn for all n. So if limit of xn, so xn and zn are convergent, limit of zn are equal is equal to alpha, then yn is also convergent and limit of yn is also same number alpha. So what is the situation actually here? There are three sequences, and for example, if you look at sequence 1 upon n cube, suppose this is xn, 1 upon n square, suppose this is yn, 1 by n, this is zn, right? Then is it true that x1 less equal y1 less equal z1? Is this true?
Yes, sir.
Right. x2 less equal y2 less equal z2. This is also true. Correct. And therefore, in general, for each n, xn less equal yn less equal zn. This is true for each n. Right. For each n, this is true. Now, if limit of these two sequences, so first sequence, second sequence, third sequence. Suppose first and third goes to the same limit, and tendency of second sequence is to remain in between first and third, so it has no choice, it has to go to the same limit. Right, so that means the second sequence is sandwiched between first and third, and if first and third goes to the same limit, then second has to go to the same limit. That is what the sandwich principle or squeeze. The second sequence is squeezed between first and third. Okay, so let us see the proof. Okay, so what is given assumption? So given that xn less equal yn less equal zn for each n. That means each n means what? Every first term of three sequences satisfy this, the second term satisfies same inequality, and so on. Every term satisfies this inequality. Right. So what is second assumption? Limit xn is equal to limit zn is equal to alpha. Right. What is our claim? What is claim?
Limit of yn is equal to alpha.
So limit of yn is also alpha. So this is our claim. That means what we want, that is, what is our claim, what we want to prove?
For epsilon greater than 0, there
Ah.
exists a case such that
For given epsilon, there exists k such that yn minus alpha is less than epsilon for all n greater equal k. So this we want. Right. This is our aim. Okay, so how to start the process? How to start the process? Given epsilon. So our process starts with epsilon. Epsilon is given. Then our process initiates. Right. So given epsilon, want k. That is our aim. Fine. Then so how to use given data? Since xn converges to alpha, right? So xn converges to alpha. So what? This is an assumption, right? Xn converges to alpha. So for this epsilon, there exists some number k. Let us call it as k1, such that xn minus alpha less than epsilon for all n greater equal k1. That means, am I right? Is this true?
yes, sir.
For all n greater equal k1, right? So let us simplify this further. That means alpha minus epsilon less than xn less than alpha plus epsilon for all n greater equal k1. Right, so let us call this as expression 1. Also, limit of zn is alpha. That is assumption, right? Therefore, for same epsilon, right? So epsilon which we have already selected, for that same epsilon there exists k, right? But that k may be different from k1, so let us call it as k2, such that after k2 Zn minus alpha is less than epsilon for all n greater equal k2, because sequence is different, so the number k is again different, right? That means alpha minus epsilon less than Zn less than alpha plus epsilon for all n greater equal k2, right? So now you remember what is our aim. We want to produce k such that yn minus alpha less than epsilon, such k we want, right? So what should be the proper choice for k? So call this expression 2. So for what values of n 1 and 2 are true, 1 and 2 hold, expression 1 and 2.
Maximum of K1 and K2.
Right. So let k is equal to maximum of k1 and k2. We found k1 here and we found k2 here. Right. So let us take maximum. So that is k. Then if n is greater equal k, then ultimately n is, when I say n is greater equal k, that means and k is greater equal k1 as well as k2. So when I say n is greater equal k, it means n is greater equal k1 as well as k2. And therefore if n is greater equal k, that means n is greater equal k1. But if n is greater equal k1 by expression 1, what I can say? By expression 1.
Alpha minus epsilon is less than xn is
X,
less than alpha plus.
right, but xn is less than or equal to yn for each n, no problem whatever is n, right? And yn is less than or equal to zn, no problem whatever is n. And since n is greater equal k, so ultimately n is greater equal k2. But if n is greater equal k2, what is happening? Zn is less
Zn
than.
is less than alpha plus epsilon.
So what ultimately we get? Therefore, alpha minus epsilon less than yn is less than alpha plus epsilon for all n greater equal k. This is true. That means minus epsilon less than yn minus alpha less than epsilon for all n greater equal k. That means absolute value of yn minus alpha is less than epsilon for all n greater equal k. So therefore, given any epsilon, are we able to produce k, whatever is epsilon?
Yes.
And
Yes, sir.
what is the process? So we can produce k via just produce k1 for alpha xn, produce k2 for y zn, and take maximum. That is the k which is required k for yn. Right. Uh, Therefore, given any epsilon, there exists k such that yn minus alpha less than epsilon for all n greater equal k. So this means, therefore, limit as n tends to infinity yn is equal to alpha, right? And hence limit of yn is same as limit of xn is same as limit of zn is equal to alpha, provided xn and zn converges. If xn and zn doesn't converge or doesn't converge to same number, then this is not possible, right? So let xn is equal to sin n upon n. This is my sequence. What is the limit of this sequence?
0.
0. Why? Why? Is it true? What I have written is true?
Yes, sir.
Right, because absolute value of sin n is less than or equal to 1. What is the reason? So absolute value of sin n is less than or equal to 1. So minus 1 by n less than or equal to sin n by n less than or equal to 1 by n. Right, and this is true for all n. Now I can call this as xn. Okay, I am calling this as xn, no problem. I will call this as yn and this as zn. Then what is the situation? What is my yn? Is 1 by n. What is my xn? Sin n by n. And what is my zn? 1 by yn is minus 1 by n. And yn is less than or equal to xn is less than or equal to zn for all n. And what is limit of yn?
0.
0. And what is limit of zn? Is also 0. So therefore these two extreme ends converges to 0. So therefore can we conclude that limit of xn, or what is xn, sin n upon n, is also 0 by sandwich principle, right?
Yes, sir.
Now,
Yes, sir.
so this sequence was easy in some sense. Let us look at some non-trivial example. Let xn is equal to 1 upon 1 plus n root 1 upon 2 plus n right. So what can you say about this sequence? Okay, so can you tell me what is x1? What
1
is
by
x?
root 2.
1.
Right, 1 upon root 1 plus 1, because xn is sum up to n plus n. So we have to stop here. What is x2?
1 by root 2 plus
1
1 by root.
Right, we have to stop up at 2. So similarly you can
Sir, it's 2 plus 2, no?
okay, 2 plus 2, right. 2 plus 2. Okay, I have here 2 plus 1 and 2 plus 2, right. 3, 2 plus 3 plus 1 upon root 3 plus 3. Great, this is third term. Now we want to see what is the limit of this sequence. Right, can we use sandwich principle here? Let us check. Now xn is 1 upon plus 1 upon right. Now xn is a sum of n numbers, x3 is sum of 3 numbers, x4 is sum of 4 numbers, right. So among these n numbers, which is the largest one? Which is largest one? Which is largest one?
1 by root of 1.
First term, 1 upon
X1.
or root of 1 plus n.
Okay, very good. So 1 upon this. Now I will replace this second also by this 1 upon 1 plus n. I will replace third also by 1 upon 1 plus n. 1 upon 1 plus n. Because what I am using here, I am using the fact that 1 upon k plus n is greater equal 1 upon n plus n for all k less equal n. Right? This fact I am using actually. So I have replaced this 1 upon root 2 plus n by 1 upon 1 plus n. So this is larger than this. Say third also I am replacing this. So last one also I am replacing by 1 upon root. So this sum is larger. Is it true?
Yes, sir.
Right. But how many numbers? So this is a sum of same numbers. And how many are these numbers?
N.
N numbers. So it is n upon root 1 plus n. Right. Also, if you look at xn, which is the smallest among these n numbers in xn?
1 by root over n plus n.
Last term.
Right, and therefore I will, if I replace each term by last term, so 1 upon root n plus n, 1 upon root n plus n, that means 1 upon root 2n, and so on. And if I compare with xn, right, if I compare with xn, that is 1 plus n, which is xn, then we know that this is larger. Xn is larger, right? And therefore, what is this sum of equal numbers? How many numbers? N. Is this true for all n?
Yes, sir.
Right. So the previous one is also true for all n. Let us call this as 1. Let us call this as 2. So from 1 and 2. What is the situation? N upon
But sir, their limits are not equal. No?
limits. Let us see what happens. Let us see what happens. This is less than or equal to n upon this is true for all n. Okay, now if smaller thing, what is this root n upon root 2 less than or equal to xn less than or equal to root n upon square root of 1 plus 1 by n. Anyway, whatever is this, not an issue, but from previous discussion, what you can say, this is a smaller sequence. Let us call this as yn is equal to root n by 2. Then what is limit of yn?
It does not exist.
Does not exist, man. This tends to infinity actually. Does not exist, or this limit is infinite. Right? And therefore by our previous discussion, limit of yn is less equal limit of xn, and therefore what is limit of xn? What is limit of xn? See, smaller sequence goes to infinity. So what about larger? Xn is a larger than yn.
It will also go to infinity.
Right? If no choice, it will go to infinity. That means you can say does not exist or diverges to infinity. That means xn diverges to infinity. That is clear, right? No doubt. Because our sequence xn is something directly we cannot see where it is going. But from this we can definitely say that xn diverges to plus infinity. Right?
Yes, sir.
Okay, let us see another example. Xn is equal to plus plus 2 upon 2 plus n square. Okay, plus, okay, let me take some different sequence. Okay, let xn is equal to 1 upon 1 plus n, right, plus 1 upon 2 plus n plus 1 upon n plus n. Look at this. Now I am removing square root. Okay, now according to the previous arguments, can I say that xn, which is 1 by 1 plus n, 1 upon 2 plus n plus 1 upon 2n is less than or equal to 1 upon 1 plus n plus 1 upon n 1 plus n plus 1 upon 1 plus n, which is n times 1 upon 1 plus n. Is it correct?
Yes, sir.
Yes, sir.
Yes, sir.
Replacing each number by larger. Also, can I say that 1 upon n plus n, 1 upon n plus n, 1 upon n plus n numbers less than or equal to 1 upon 1 plus n, 1 upon 2 plus n, 1 upon n plus n, which is xn. Is it true?
Yes, sir.
Yes, sir.
And therefore n times 2n n times 2n is less than or equal to xn for all n. Right? So therefore 1 by 2 less than or equal to xn is less than or equal to n upon 1 plus n for all n. Right? But here both ends do not converge to the same number, so we cannot say that xn converges to some. So what is happening? Limit of 1 by 2 less than or equal to limit of xn is less than or equal to limit of n plus 1 by n. Right. Now what is limit of half is half, and what is limit of this n upon 1 plus n?
1.
1.
Okay, so from this what information we get? What information we get from this? Is limit xn belongs to half to 1, because both ends do not converge to the same number, so we cannot say limit of xn is definite information we do not get from this. Okay, so the example which I want is different. So both ends converge to same number. That example I want basically. So what is that example? I am looking for some non-trivial example. Anyway, can we say that sequence xn is convergent from this?
No, sir.
Yes.
Why not? Why not convergent?
Sir, because it belongs to the interval, no? So,
No. We get information that limit is in between half and 1.
yes, sir.
Right. So there are possibilities. It may converge or it may not converge, but this sequence converges due to some reason. And what is the reason?
Sir, but limit, like, it cannot converge to 2 points, no?
No, it cannot converge to 2 points. Limit is in between. So for example, if you look at sequence xn is equal to 1 by n, right? Then can I say that limit of xn belongs to minus 1 to 1? Can I say this?
Yes, sir.
Right. That is what I am saying here. The limit is in between half and 1. That is the point here. But I am saying that whether from this it is not clear that whether limit exists or what is the limit, what is the number, exact number which is the limit of this sequence. That is not clear from this. Only thing is if limit exists, it is in between half and 1. That is what the information we get from this.
Okay, sir.
Right. So okay. What exact sequence I want to produce? So okay. Now to understand whether limit of this sequence exists or not, this calculation guarantees that limit is in between half and 1. But from this it is not clear that limit exists or right. So to understand this we have some results. And what is that result? So a sequence xn is said to be monotonically increasing if xn is less than or equal to xn plus 1 for all n. So sequence is monotonically increasing if xn is less than or equal to xn plus 1 for all n. What does it mean? what this definition says. What is the meaning of this?
Each term of the sequence is greater than its previous term.
Right. So what did it suggest? That is x1 is less than or equal to x2, x2 is less than or equal to x3, x3 is less than or equal to x4, and so on. So next term is bigger than or greater equal previous term. So for example, xn is equal to 1 minus 1 by n. Is it monotonic increasing?
No.
Yes, sir.
Yes, because what is x1? 1 minus 1, which is 0. 1 is here, and I am subtracting 1 by n every time. So first term is 0. Second term I am subtracting half from 1. I am subtracting half from 1. So I am here. Next time I am subtracting 1 by 3. The amount that I am going to subtract is reducing, and therefore the value is increasing. Right. So what is x2? 1 minus half, which is half. What is x3? 1 minus 1 by 3, which is 2 by 3. Right. So the amount that I am subtracting is reducing, and so the difference is increasing. Or can you prove in general? So we have n is less than or equal to n plus 1. Therefore 1 by n plus 1 is less than or equal to 1 by n. And if you multiply by minus 1, 1 less than or equal to minus 1 by n plus 1. Add 1 throughout on both sides. So 1 minus 1 by n is less than or equal to 1 minus 1 upon n plus 1. And therefore, what is this? And what is this? This is left hand side is xn, right hand side is xn plus 1. This is true for all n. Correct?
Yes, sir.
Yes, sir.
Therefore, xn is monotonic increasing. Right. Now, if I give you a sequence 1 plus 1 by 2 plus 1 by n, if this is my nth term, okay, what is x1? We understand what are the terms here. What is x1?
1.
1. What is x2?
1 plus half.
3 by 2.
1 plus 1 by 2, which is 3 by 2. x3 is 1 plus 1 by 2, sum up to 1 by 3, right, and so on. You can understand this now. So what is xn? 1 plus 1 by 2, sum up to 1 by n. Right. So what is xn plus 1? What is the next term? If this is nth term, what is the next term? Xn plus 1. So what is it?
One.
Right. Sum up to 1 by n plus 1. What is the second last term in the xn plus 1?
1 by n.
Right. And so if you separate these terms, so this is what the bracket is xn actually. Right. You understand? And therefore xn plus 1 is xn plus some positive quantity. Right. Xn plus 1 is xn plus positive quantity. So certainly it is bigger than xn. This is bigger than xn because xn plus some positive amount is greater or equal xn. So no doubt. Or alternatively, what is xn plus 1 minus xn? What is the difference?
1 by n plus 1.
1 by n plus 1. Is it positive amount?
Yes, sir.
Yes,
Right?
sir.
So that means difference between xn plus 1 and xn is positive. What does it mean?
Xn plus 1 is greater than xn.
Right. Therefore, I can say that xn is monotonic increasing. It is monotonic increasing. The previous example which we discussed, Is it monotonic increasing? What is xn? 1 upon 1 plus n. Is it monotonic increasing?
Yes, sir.
So check this. Write down xn plus 1 and xn. Write down the difference. If difference is positive or difference is negative, accordingly we can decide. So 1 upon 1 plus n plus 1. Right. This is xn plus 1. I am writing xn plus 1. 1 upon 2 plus n plus 1. And so on. 1 upon n plus 1 plus n plus 1. Okay, what is second last term in this? N plus 1. Right. Minus, what is xn? And now calculate the difference. So which terms getting cancelled? And which terms survive?
1 plus 2 by 2 plus n.
Yeah, so
And 1
see,
by 3 plus n.
or if I write in detail 1 upon 2 plus n, right, because 1 plus n plus 1, so 1 upon 3 plus n, this is xn plus 1, 1 upon 2n plus 1, and what is the second last in xn plus 1 upon 2n, 1 upon 2 plus 2n, this is xn plus 1, minus, what is xn in simplified form, 1 upon 1 plus n, 2 plus n, up to 1 upon 2n. So which are getting cancelled? So this cancels up to 1 upon 2n cancels, and what survives? Minus. And now you calculate this difference. You check whether this difference is positive or negative. So you think about it. Accordingly, you can understand it is increasing, decreasing. Is it clear?
Yes.
Yes, sir.
Okay, so
Yes, sir.
you work out it. Next time we'll see. Right? So think about it, because if sequences are increasing, decreasing, that helps us to understand the convergence. Right, and so we can understand convergence of some complicated sequences if you understand this. So just think over it. Next time we'll discuss it.